Yes, sir, let's do it. Wait, let me check.
Okay. So
Okay, yes. So we can
we should
start
do
with
we should
part.
do everything, yeah.
Yes, everything there, sir.
Okay,
Everything.
okay, okay. Okay. Now, the first of the displacement y against distance against time is given this form. So you have wave P as it passes through point P as illustrated in the. Use this to determine the frequency of this. This is easier one. You know why I don't like sharing my entire screen? I don't like seeing this here, as I have to write it. I like to see it on top here. Let it be on top. That's
Oh,
this particular. That's why I just say by this. I don't even accept. I hide it, and I don't like hiding it. I like to see it on top here. That's why I don't like see the entire screen. Now, we want to determine the frequency of x. This is very simple to do. Thank God. Like I said, thank God this is a.
let's skip that one.
Okay, okay. So which one again?
The part where I
From
had
here,
to.
right?
Oh yes.
It's
Had
from here. It's, okay. We might also need this information anyway. The question says the second wave with the same frequency. What did you get as frequency here? Tell me first. It might be needed. So
250. I got 250.
250. Okay. 250 hertz. Okay, fine. Now the second. The second coming. Okay.
Yes.
The second we said with the same frequency. That means having the same period. For it to have the same frequency, it's having the same period. So that's what we want to know from that. Same frequency means it's having the same period. And they also pass it through point P. And you have the phase difference. Oh, you are giving phase difference. So scale the variation of this. Oh, okay. Phase difference is 90. That means it's going to be interval of 90. So then now see from here to here should be 90, 90, 90. So that means it's going to be different in this different in the distance. That will be the 90 degrees. So we want to sketch the displacement of the variance of x of z. You need to know the new amplitude. Look at this one now. They say whereas intensity too high. So that intensity of the first one is high. Did they say so? Of course, it should be high. X is high, you can see now. So in that case, this is intensity of x, it is high. Intensity of z is too high. Are we together?
Yes, sir.
Okay. Don't forget that I said intensity varies as well, amplitude square. So meaning that can have intensity over amplitude square is equal to what? A constant. So meaning that can have intensity 1 over amplitude 1 square is equal to intensity 2 over amplitude 2 square. So in the other way around, I can also write in form of x and z now. I can just say intensity x over amplitude x squared is equal to intensity
Mhm.
z over
Physical
amplitude z squared.
intensity
Are we together?
square squared. Yes, sir. We're together.
Okay, fine. So I'm making use of this one now. So I need to
Hello.
wipe.
Can you hear me?
Yeah, I can hear
Yes,
you.
sir.
Okay. So moving on to this now. So making use of I want to get the I want to get the second amplitude. So let me amplitude z now. So amplitude for z square. So that is going to give me intensity for z over amplitude x square times intensity. No, divided by, okay, yeah, my math is wrong. So it will be this, then this is, okay, supposed to be this, amplitude x, amplitude x square over intensity x. Actually, I'm right. Making HZ solve the formula. Confirm for me, have you? I think it's correct. Yeah, it's correct.
Yes, sir.
Okay, fine. So you now go and substitute. You need to get that A first. So substitute now. Intensity Z is 2I. Intensity X is I. Amplitude X, yeah, let's go and get it, is 2 centimeter. You can see now, this amplitude centimeter. So you put 2 centimeter there.
Yes.
So that will give you 2 centimeter multiplied by 2, but you are squaring this. So definitely it's going to give you 4. That should give you, I think it should give you 8 centimeter. Yeah. Yes, because yes, it
Yes.
should be 8 centimeter. So you are looking for square root of 8. Now remember, a of z, that will be square root of 8. 2 point what?
2.82.
Hmm?
2.82. 2.8.
2
Yeah.
point what?
So 2.8. 2.8.
2.8. Okay. So on
Yes.
2.8 now, you are looking at 2.8 on this graph. So you can see now each one is 2 point, no, 2 point down, each one is 0.2, 2.24, 2.6, 2.8. So it to pass, it to stop here. So that is going to pass through here. Let me just get this thing. No, but I don't need to draw this time. Don't making it here. You are not drawing this line out. It's none of your business. Nobody asked you to. But I just want to, so it to stop here because it will stop here. So at the same time, for the one below, it will stop at the same 2.8. That's 1, 2, okay, and 1, 2, 3, 4. Yeah, it will stop here. So it will just stop here. I'm just, so in an exam, you are not drawing this straight line I'm drawing. I just want to locate where to pass through for easier draw. So we have gotten that step right. So the question now says the path difference between them is 90. So path difference is 90. So you cannot from here to here, that is going to be here. From here to here is 90. So if you don't even know what should be the time, okay, but we don't know we know the period, okay. So if at all you want to even work it out, path difference is phase difference is t over this times 360. 360 degrees. So you're having 6 to be 90 degrees. I want to get the small time t, small letter t. So small letter t here. The period is from here to here. Period will be 4 milliseconds. 4. So multiply by 360.
Let
What
us.
should be small letter? Period is from here to this place should be 4.
Mm,
So yeah, can you work out this small letter t for
it's
me?
5. Oh,
That's
it's
1.
minus 1 is 4.
That's
Okay. Yes. 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 I agree.
that's the 1.
Yes.
So the time difference is 1. So that means the time difference is 1. So it's going to be passed through this. It's going to pass through this because you can see it's going to pass through these points, and
Yes.
that's all. Yeah, it will pass through this point, because from here to here is 1, from here to here is 1, from here to here. So time difference is going to give me 1. So that's how to, so nothing passes through. So it's going to pass through. So to put it through now, okay, let me just try to use my free hand here. So it's going to pass through this, fine, and this to this, and so on. So it will be this. So this will be middle of this one. Okay, let me try to locate this point. I just want to make it clearer. Let me use something different for this point here. So it will be on this point, and also it will be on this point. And wait till when it pass through. No, I can't pass through this point. Not on this point. When it passes through like this, it will be half and it will be here. And fine. It will pass through this point. It will pass through this point and come and meet up here. I think it's here. Fine. We're able to go, I'm able to analyze where it's going to be. So let me now put a draw. So that means I'm going to draw my line like this, a sketch. Uh, don't really mind my frame, but it's going to be a curve like this. Fine. Yeah. It's going to be something like this, a curve, and so on. So this will be your Z. That's what you are going to do. Any question with that? You can see now, and the amplitude is correct, and the difference is time. Look at the difference in time now. It's 1, 1, 1, 1. So that's all. You can look at the difference in time from here to here is 1. The same thing from here to here 1, 1. So this is what you have to do. Is it understood?
Yes, sir.
Okay. Now to the question. See now. This is a double slit now. A double slit. Oh, we have a graph here. Fine. You have a double slit interference experiment used to determine the wavelength of light, blah, blah, like that. So we have the separation of the slits. What the symbol for separately? That's A. A is 0.45.
Just skip a question.
So
What?
you said what?
No, I'm saying it looks like you skipped a question.
Really? Where?
Because yes, sir. Oh,
No.
oh,
You
oh.
said is I've already done B now. It's correct now. I didn't skip any more. Look at the question. After B, A. You say you've done
Fine.
A, so
I think
I did B. So
it
it's
has the
C
one
now.
that is not.
Can we continue?
Yes, sir, we can continue.
Okay. So that is millimeter fine as A. So A the symbol for slit separation, and we have what again? The distance D. We now have X. X is called fringe separation, distance between the bright to bright or dark to dark. So X is the width of the distance, the frame width.
Yes.
What formula connects this? There's a formula that connects it. A formula that connects this is A should be
Lambda is
D.
AX over D.
Lambda D over what? Over X, have you? Yeah.
Yes, sir.
This is the formula now.
Yes, sir.
Okay. So lambda D over A, yeah, that's the formula. So let's look, if you look at this for the formula, how can we are plotting A against D? So you plotting A against D, meaning that A variable as lambda, then D. So meaning that gradient, in this case, gradient is equal to lambda over X. Are we together? That's gradient. Because if you plot this, so if you plot this against this, so this will be the gradient.
Mm-hmm.
Okay, fine. Since you agree with that, this is a gradient. Fine. So you use the gradient of this to determine the wavelength in nanometer. Okay, fine. So let's determine the gradient. So I will ask you to determine gradient here. So once we once we calculate, in this case, our gradient is lambda over X. So I'm looking for wavelength. That means my wavelength will give me X multiplied by gradient.
Yes.
So what we need is to calculate gradient. So which I will ask you to do here. Calculate a gradient. Let me try to. So pick any point you want to pick. You can pick the first and the last one. It's okay. This
Yes.
one and this one. Oh, yeah.
Open it and uh
If you pick that and this, so that this is good. Yeah. What will be the value of this point? Yeah. This is yeah. What is calibrate this point? Calibrate this point.
4.8.
4.8. So
Yes.
it's millimeter. So it's in millimeter already. We are going to nanometer. So maybe first of all convert it to meter first. So 4.8 minus 2, Abby. So 4.8 minus 2 over what? That will be 3.5 minus what? 1.5. Are we together?
Yes, sir.
Okay. Convert this one to meter first. That's power minus 3 millimeter. So this is in meter, right? This one is in meter. You don't need to convert. I put the calculator. 2.8 power minus 3. Then over, I think this is 2. 1. I think 1.4.
Yes, sir. Yes, sir.
1.4 power minus 3. So gradient is 1.4 power minus 3. So
Yes.
we now have lambda is what am I looking for? No.
The gradient. And then
Okay. No, let me see something. I need A is okay. Oh, something is wrong. No, it's correct. But what I did is it is X that is plotted against D. So I have used A against D. So it's wrong. So I have to rearrange the equation here. So let me rearrange the equation here. But the gradient is correct. So let me rearrange the equation here.
yes, sir.
Let me just, okay.
Lambda equals to AX over
Uh,
D.
so I have this lambda over X. I'm looking for lambda against D. So what will be?
Over D.
So I'm looking for x against d. So that will be what? It's equal to what? Lambda over a. Abi?
Yes, sir.
That's this. This is correct. So x against d now is correct. So this is x against d. So my gradient is lambda over a. So in this case, gradient is lambda over a. It is over a. It is over a. Lambda over a. So here is lambda over a. Lambda over a. So that will now give a multiplied by this. So a is given as 0.45 millimeter. A is 0.45 times minus 3. That's in meter. This one we got 1.4 and 1.4. This is, I think, 1.4 here.
Times 10
1.4.
negative 3.
I do the mathematics. Let me see.
It's 6.3 times 10 to the power negative 7.
Minus 7. So we are moving to nano. So how do I get nano? I'm moving forward, Abby. That should be 630 nano. If I move here one, I have to move 2. It should be 630. Do you understand? This is the same as 630 power minus 9 meter. Do you understand why I got 630? You are moving twice. When you move to the right, negative will increase.
Say?
Do you understand why I got 6 from here to 630? When you
No.
move this point to the right, the power of negative will increase in the standard form now. When you have 6.3, if you are moving twice, if you move 1, that should give you 63. You move it 2, that should give you 630.
Oh,
So you move
okay.
it 1 and 2. So in mathematics, it will be 630. So this is correct. So 630 nanometer will be correct.
Yes, sir.
Okay. So that's that on that. Okay. Now, next one. The separation of the slit is increased. We increase separation of the slit. We increase what? A. A is increased. That's what it means. It means
Yes.
A is increased. Okay. So it means we increase. It means A is increased. A is A is increased. So if you increase A, what's the effect? Remember, we have gradient is equal to lambda over A. So meaning that gradient G, let me say G for gradient, lambda over A. So if you look at it, gradient and A, they are inverse. If you look at it now, gradient G inversely proportional as well, A.
A.
So what happens? If A increases, what happens to G, which is gradient?
Decreases.
Thank you. So the first thing is gradient decreases. That's all. So that's the first thing. So state and explain effect on the graph of this. What should be the effect? We are stating it. So in this case now, from here, meaning that, so this one means that first thing, gradient does what? Increases. Gradient. Gradient decreases. Gradient, which is lambda over A, decreases. Yeah, because we are increasing A. So what's the next thing? If it decreases, so what happened to the shape of this graph? If gradient decreases, that means the what? The line is going to fall below. It's going to
Yes.
fall below the graph. Because if we have to draw another line now, let's starting from it should be something like this. Yeah, it has to be below. So because
Yes.
this one gradient decreases, if its gradient increases, it will be above. So that's all. Therefore, the line falls below the what? The original line. So that's all. Decreases and the second or the graph. We can say the graph falls below the original graph. That's all. So the line or graph, anyone. So that should be the reason. This is yes or no? Abi? I think this is the question. Can you
Yes,
hear
sir.
me?
Yes, sir.
Okay, okay, okay. We have a
Okay.
apparatus to produce stationary waves on the stress strain is shown. This the frequency. This is we have polling. Okay. Describe two adjustments that can be made to the apparatus to produce stationary wave. You want to produce stationary wave. So if you have to produce stationary wave, I think so here. There are a couple of things you can do here. Number one, you have to change the frequency from the frequency generator. You have to vary the frequency. So that's what it means. So that's what you have to vary the frequency too. You can also change this mass. The possibility. I think there are only three things you can do. You can't tamper with pulley. You can change the distance between the vibrator and the pulley. That let me put it to. There are possibility, which is three, or which are possibilities are three. So you tamper with this one, you can tamper with this, you can also tamper with this. Any other thing, nothing. So there's nothing you can do. You can't tamper with a live edge. This is a vibrator. There should be a vibrator that will vibrate, that will generate. This one is constant. Then put this also constant. But you have here, you can move this vibrator to something else, to where. So that means you can change the distance of point to one. Anyone you can use. Is that you vary the frequency from the frequency of the generator. So that's the possibility. Vary the frequency from frequency generator. Are you noting that?
Yes, sir.
Okay. So you can vary the frequency from frequency generator. 2, change the mass. You can change the masses. 3, change the distance between the vibrator. Maybe I should write any possibility. So changing the distance, the vibrator, and the pulley. Another possibility, you can change the mass. Another possibility, vary the frequency, vary the frequency from the frequency generator. So these are the three possibilities. Any two.
Yes, sir.
Is that okay?
Yes, sir. That's okay, sir.
Okay. Okay.
So let's go to
Now,
complete.
the next one, Abi, this one. Describe the features that are seen on the spread string that indicates stationary waves. Yes, now. What do you see stationary wave? Stationary wave, there are 2 points. We have what is called load and anti-load. Yes or no? So, number you see the amplitude, that is, the amplitude varies from maximum to minimum or to zero. So those are the features you can see. So you can see the amplitude, what you can see, the features here. So the feature means the amplitude. First of all, you see the amplitude. That is, amplitude is seen.
Yes, sir. I was saying that if I wrote
Okay.
about the node and antinode, I'd still get my mark, right, sir? Because the same
And
thing is
see the way you want to run it. Just put it this way, and it varies from maximum. Not say what's maximum? antinote.
Yes.
To 0, which is called what?
The
Maximum to
node.
0, 0 node. That's all. Because there's no minimum
Oh, say,
hand. So this is
then
safer this way.
I wrote I wrote from antinode to node. Say, would I have
Okay,
gotten a mark in the final exam?
from antinote, you might. You might get it, but not at times they can be they are unpredictable. Their mass can be used to figure out from one place and even same question from different year. They may have different masking. But anytime you come across this, just try to put into brackets, yeah, to be on safer side. Talk of maximum. I say you have no do what I call now. You have already defined amplitude by you have defined amplitude by say this is the maximum displacement. You are saying no the circle displacement.
Okay.
So that means that's another way you have defined it. You have said amplitude, but it's maximum amplitude. You are saying no, zero amplitude. Do you get it now?
Yes, sir.
Okay. So we put that one there.
It's good. Part B. Yes. Part
So,
B, sir.
okay. Which one?
Part B. The one for the diffraction gradient.
Okay, see the I didn't want sorry, I didn't want to. I thought it has ended. So we have this. Okay. This is an interesting part. The variation with time of displacement. Let me just leave this story.
Yes,
Now we
I
have
can't. I can't see.
you can see my screen.
No, I cannot.
You cannot see it. Eh?
Oh, okay. Yes, now I can see it. I can see it now.
Okay. So you have this again, this we have S and R. Okay, determine the phase difference between the two. Phase difference between the two. So if you were to determine the phase difference between R and Y, X. So okay, let me see. What's the time difference between this and this? So let's look at it. First of all, they have the same period. They should have the same period. This from here to this is 6. Look at this one to this as well. So this is
Yes,
no this one. Wait, this one to
6.
this and it's 6 is 6. 0.6, 0.6, that's the period. So capital T is 0.6. Small letter T, look for it. You are looking for this or no. So look for some what's time difference from here to here or from here to here. Either from here to time difference between the two. From here to here, which is what? 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5. I think it's 1. 0.1, Abby.
0.1. No.
It's 0.1 now. The time difference.
Between R and S.
Yes, now just from here, just this here, from what's the difference in time from here to here, or from here to here? What's different in time, or from here to here? The same thing, or from here to here? What's different in time? It's 0.1 now. From here to it's 0.1. It's 0.1. Time difference from here to it's 0.1.
Oh,
You see me,
that's what.
you don't
Okay,
get it.
yes. Oh, okay, yes, I get it.
So the time difference is 0. That means small letter T is 0.1. Capital letter is 0.6. You are looking for this or no. What's the formula? This is equal to this over this times what? 360. You are working, it's in degrees. You are working in, okay, okay, whatever unit you use. So we are working with degree. We are going to put unit. Here, press calculator. Put and press calculator. 0.1 over 0.6 times 360.
60.
Hmm?
60.
60. Okay. So you are working with 60 degrees. So you want to work with degrees, so 60. They say put appropriate unit and include an appropriate and whatever unit you work. So you can say 60 degrees. If you want to work with radian, no problem. Remember that you say 1 pi is equal to 180 degrees. So that means 60 degrees equal to x. Multiply in terms of pi now, that will give me what? 60 over 180. So 0.006 here. That's 1 over 3. So 1 over 3 pi radian. So it's the same thing. Either this or this. So any unit. Just put appropriate unit. Is it understood?
Yes, sir.
Okay.
Yes, sir. I
Now,
think the one for
okay.
the ratio, I managed to get the answer.
You can get that right?
Yes, sir. That one is fine.
Oh,
So let's go to
ah, okay.
2016 November 21.
2016 November 21.
Yes, sir. Question 5.
Okay. 2016. I'm coming. Can you see?
Yes, sir.
Okay. You can define this one, the first one. You have the
Yes.
business in your, it's
The
a
best
note, it's a note.
it.
So,
I managed to do that one. Let's skip it. Let's go to part B.
okay, from B, okay.
Yes, sir.
Calculate the difference, okay. So you have a light, a wavelength, 500 nanometer. Is it then normally? What not normally? 90 angle is 90 degrees. So in this
Say
case,
how,
now you are not giving the angle is 90 degrees. If you are not giving the angle, that's the maximum angle. You cannot get beyond that. So if you are not giving the angle and you are not looking for the
say
angle,
if
so if what? Hello?
okay, say as if you are not given an angle, then it's automatically 90.
Yeah, if you are not giving, and the question will tell you is normally. It's normally. So the four incident here is 90 degrees. 90 degrees. That's all. And you are not asked to calculate the angle.
Oh,
So the angle
normally. Oh, yes.
you
Ish,
take
ish,
it to be
ish.
90. You are
Okay.
not asked to
Yes.
calculate. So you take it to
Hmm.
be 90.
Okay.
Now, so here is I think you can do this now. It is this sign, let me see,
Say
n lambda.
say
The first one, so that we are okay, fourth
oh.
order. So fourth order, n is what for fourth
My
order? N will be what? Wait, fourth
your
order
voice is
maximum. N, hello. First order
your
maximum.
voice
What would be the value? My what?
your voice was cutting. May you please say what you're saying again?
Okay. Now, in this case, is it then normally? That's point one. And you are
Yes.
not asked to calculate the angle. So if you are not asked to calculate the angle and incident normally, so the maximum angle you can get is theta is 90 degrees. That's the you can't get beyond 90. That's the maximum. So it is 90. So you take it. So sine theta is out of the way now because sine 90 is one. So but you have to write it out like this to get the form together. And you write it out first. So you are going to write as in fact you have to include it first for you to get because I know Cambridge crazy. At times they want to see like this. So you are now having this equal to n lambda. That's all because sin theta is one, sin 90
Say
is one.
you.
So you write it out like this first. Don't just start from here. Don't
Yes, sir.
start from n lambda. You follow from here. So you follow from here actually gives you something. Now from this particular one, fourth order. What mean of fourth order? N is 5 for first order because second order, look at it. Go and I explain it like this. Second order, N is 1. So take N is 0 for second order. So,
Say
okay, this
for
is second.
the, for the
I'm
zero
coming.
order is one. I don't understand.
No,
Explain.
no. Second order, N is when I explained the node the other time. This is the formula. N start from 1. N start from 0 here. N start from 0. N start from 0. And so the fourth for second order, N is 0. So this is second order for first order, second order, third order. This one n is
So
0. This one n is
four.
1. If n is 2. Fourth order means n is equal to 4. So that was
N is
it.
4.
4.
N is 4 for
Fourth order. Yes, n is
okay.
4. Fourth order. So n is 4 for
Then
fourth order.
the rest is just substitution. We can go on to part C.
You can put the. So this
Yes.
one's the light is now replaced with a red now. A red. The light is now replaced with a red color. Okay. Remember, under red color, if you go and check the table, there's a table just hold on, let me go and bring it's in the note that I forwarded to you, but we did not explain because you asked me to start from superposition of waves. So we did not start from there. So let me go and get. You can see my screen, right?
Yes, sir.
Okay. So you have all these notes already. So I have a table here. Yeah, you see now. These are called visible light. You can see now visible light. Start from this to this. So what's visible light? You can see from here. Look at it. So these are called visible lights. You can see now. See,
Yes.
red. So visible light start from the first one is red, last one is violet. So we only know the wavelength for first and the last one. In between, we don't know it. We don't know.
Yes.
So if you look at it now, the red one is 700 nanometer or 7 experimental did, while the violet one is what? 400 nanometer. So that's all. So I'll come back. So you will replace with a red. So for red now, wavelength for red is 700 nanometer. So that's wavelength. So what was wavelength before? Wavelength was what? 500 nanometer. Wavelength of light, according to that, we have 500 nanometer. What can you say about wavelength? Does it increase or decrease?
It increased.
It increases. So it increases. You are moving from that's moving from 500 to 700. So wavelength increases. State and explain whether it likely results in the formation of fifth order. Fifth order means n is 5. Now,
Yes.
wavelength has increased. So in this case now, so the point one, the first point now, nobody has to state the value. So the first point is that the wavelength increases.
Yes, sir. Wavelength increases. Yes, sir.
And that's increases. Now, if wavelength increase, come back from, you are looking for fourth order, whether it's going to give you fifth order. How do we know whether the fifth order is possible? Go and look for angle theta from the formula. Come back here. This one
Yes,
will
so
determine. Don't put 90.
you
Just look for theta and lambda. So anytime you get 90, you get value for theta, and it's between 0 and 90. That means it is possible for diffraction. I come again.
okay? This
Whenever
one.
you calculate theta, and the answer of theta ranges from, is right down at your end, theta ranging from 0 degrees to 90 degrees. So in this case, the diffraction is possible. The formation is possible. Whether we the likely result in formation of this, so it's possible. But if it's 90, if it's from 90.1, it is and above, greater and above. Am I right? It's not possible. Are we
Yes,
together?
sir.
Okay,
Yes,
it's
sir.
not possible. So we want to know whether fifth is possible. Fifth means n is 5. So you are going to look for it. Use the wavelength now. Yeah, use the formula now. Go and look for theta. You have the wavelength. Your n is fifth n is 5. Then d is d not giving?
So for
Wait, are we not giving d before?
yes, sir.
Okay,
I give
it's
it.
d you are looking for. No, it's d you are looking for. We have to do no, you have to calculate this. Let's calculate d from here. Here, you have to
No,
calculate
sir.
9 space.
I, I calculated it. It's 2.0
Okay.
times the power negative 6.
Like this, Abby.
Yes, sir.
Okay, I come and use it here. I use it here first. So use it here to look for theta. When you get theta, we will find out what will happen, whether it is possible or not possible. I do for theta. Put the value of wavelength, convert it to meter. This is your wavelength now is now 700 times what? Power minus 9 meter. Yeah, put the value of n as 5. N is 5. D2 power minus 6. I look for theta. Let's see what we'll get. If it's possible for you, we'll know.
Okay. I'm not getting that. Why am I not getting?
You're not getting anything.
Yes, sir.
Okay, it's not okay. It's not. It's giving you math and calculator,
Yes, sir.
and that means not possible. So that's all. As long as you cannot get that value for theta, so that means not possible. So it's not possible. Why? Because the angle the angle is greater than 90 degrees. That's what's happening there. So fifth order is not possible because as the wavelength increases. So if you look at it now, so you can't get a value. So it's not possible. So point one is settled. So in this case, if you look at it, so that if you look at the wavelength, that is wavelength very as well, sine theta. So as the wavelength increases, therefore the angle increases beyond 90. So it is not possible. So angle increases beyond 90 degrees. So therefore it is not possible. Fifth order is not possible. Did you get it now?
Yes, sir.
Okay, still hold on. Go and look for third order. You should know that one is going to be possible. Look for third order. You have this just to clarify something. N lambda. Third order means n is 3. Put n to be 3. Put wavelength. You see now, it will be possible.
For
For just, I want to
okay.
confirm something. Calculate for third order. So n is 3. Put it. It will be possible. So it will be possible. Yeah. You must get a value. Did you get a value?
I'm doing it.
Okay. And you are going to get a value.
I'm saying I'm still not getting the value.
I'm coming. So it's going to give me sine n3. Your lambda is 700.
How did you get?
9 over d. D is 2. Minus 7. No, minus 6. So it's supposed to get a value. So this will give you 7. Okay, this will give you 7. That's 21 power minus 7 over 2 power minus 6. That should give me 10.5 power minus 1. Oh, you can't still get, it's giving me, and it's not possible for red. It's not possible for red. Red will not occur because it's too much. Because this is going to give me this. So that will give me 1.0, 1.05 or 1.1. You can't get it 1.1. You can't get it. Don't worry. You can only get for 2. No, this is 3 now. No, that's a mistake.
Are you sharing a screen?
Okay, this is 21. If it's 2 now, it will be possible. 2 times that was 14. That will be possible. It might not get down. Don't worry about that. But this is just the answer. So that's correct. So it's not feasible for red color. So anyone, there are a lot of questions on waves. In fact, that will even prompt me to even go to a lot of questions on waves now. I sent you. So let's even go. Do you have anyone available? Or maybe you can use the idea to go through. Or there are still, I want you to see under waves of this type. I want to explain something. Maybe we should just go into it now. Or do you have any?
Wait, sir. Let's do this question before we can go on to.
Okay, well, tell me the next one.
Yes, sir. Okay. Let me look at this question. So it's 2009. Say pure
2009.
21 question 5.
Which one? June or which one?
June. Yes, sir. June.
June 2009. Number what?
Question 5.
5. Is it this? Cross check the question. Is it this question?
I can't see.
We can see. And I'm saying, okay, 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 don't worry.
Yes, yes.
Okay, 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 fine. You said number 5. This one?
Uh, let me see. Yes, yes. That one. That one.
Ah,
Yes.
okay. Now we have state what's state the condition for that must be satisfied for the intensity of the wave, okay, to be 0. That means amplitude is 0. So that amplitude of the wave will at m. If the intensity of at m to be 0, that is overall intensity. And that means, I'm coming, that means the amplitude is 0. So if the amplitude is 0, so it means we are saying when you part difference is 0,
Keep the
all
first one.
number. So when the part
Oh,
difference is
no.
0, number. So if you have amplitude to be 0 at that point, the condition that must be met, I think the wave is supposed to be out of phase. Come on, let me quickly think about that's out of phase. If it's out of phase, we can calculate the part difference. We can. Okay, that means okay. I think I gotten the idea. I got an idea. So if the intensity to be 0, don't forget the fact that we have intensity variable as well amplitude square. If the intensity is to be 0, that's overall intensity. It means the overall amplitude also must be 0. And if the amplitude to be 0, if the density, let's say I is 0, it means A is also equal to 0. Am I right from here? Yeah. Now, if you are going to get A to be 0, when you add up the 2, because you are moving the 2, the overall now 2, that means they must be out of phase. Because when you have this, for instance, I drew this something I did that day when I was explaining. I said, if you have this value to be A, this is A. If you have another one, can you see my right? Can you see my screen? Are we together? Hello? Hello? Can you hear me?
Yes, yes, yes.
Okay, okay, you
The
can hear me. So if you have this type,
intensity is the amplitude.
okay. What do you say? Now, if you have this, look up, if you have this type now, this is positive, this is negative. If you try to add up these two now, you are going to get 0. So if you are going to say, let me say this is A, you now say A plus minus A. That will give you 0. The same thing here, if you say minus A plus A, that will give you 0. That means for me to have 0 amplitude at X, 0 intensity at X, to have at this plane to be 0, it means that the total, they are talking about intensity now, that will be total. They omit, they did not, they omit, they were silent about something. So to be total intensity, but they will not tell you. For total intensity to be 0 at M, it means that total amplitude also must be 0. And for total amplitude to be 0, the two waves must have same, the two S1 S2 must be the same amplitude. So they must be the amplitude for, okay, amplitude for S1 must equal to amplitude for x2. So when they are equal like this and they are out of phase, when you're trying to add them, we are going to get 0. I think I'm able to establish one point there now. So now with that idea that we're going to have total to be 0, the total amplitude is 0, meaning that for them to be 0, they must be out of phase, they must be cancelled out. So we have so many points to consider. So in this case, you have what is called a path difference. So you can talk of path difference. When they are out of phase, what formula for path difference is given as n lambda plus lambda over 2. Yeah, it's equal to this. We now say where n is 0, 1, 2, 3. I explained this then. That's point. Another two, phase difference. Phase difference. Phase difference must be when the waves are out of phase. Phase difference is 180 degrees. So they're out of phase. So that's all. You cannot have that. There's the major one. So it means you can also add another one to this. That is x1 and how to have same amplitude. X1 and x2 have same amplitude. Or you can say x1 and 2 they're out of phase. That's even enough. So this is major point. So these are major point. So I think you know how I arrive at this. I arrive at this by saying this. The question say the intensity at m here is 0 according to this m. So that intensity they are referring to total intensity. And if total intensity go to 0, that means total amplitude also must go to 0. And if amplitude must go to 0, that means they must be the same thing and they must be opposite. That means out of phase. Are you getting my point? Hi. Hello?
Oh, hello, sir. Sir, can you hear me?
Okay. Did you hear what I said, what I explained?
No, sir, I didn't hear what you were saying. It had disconnected.
Okay. Now, look at it. The question says the amplitude, the question says the intensity of at m, it is 0.
Mm-hmm.
Okay. So that intensity at m, they are referring to total intensity. That's all. Total intensity is that the intensity due to x1 and intensity due to x2 at m is equal to 0. It means they are referring total intensity is 0. So from here, if this is equal to 0, that means it means total amplitude also must equal to 0. So maybe it's
Sorry, sir.
yeah.
I don't think she can hear you.
She can't
It's
hear
fine.
me. Wow. Maybe
It's
our
fine.
network. But Mr. Ajiro, can you hear me?
It's
Yes.
fine. It's
And
fine
maybe it's
now.
our network.
Okay.
It's
All
fine.
right.
Okay.
All right. Okay.
You can hear me now. Okay. Okay. Thanks for that.
It's
Now,
fine.
let me start what I've explained again. Now, the question is referring to the intensity at m is 0. So this is what is happening. Intensity at m means intensity due to S1 and intensity due to X2. We don't have the intensity together. So, but let me just write a formula. Intensity at m, meaning the intensity at X1 plus intensity, sorry, at S2. But this is not conversion, it's not correct. We don't have the intensity together. I'm just used to explain, meaning total. But this is not correct. I don't wrote it like that. We don't have the intensity together. We only had amplitude together. Now, for the intensity at m, can you still hear me?
Yes. Yes,
Okay.
sir.
For intensity at m to be 0, it means that amplitude at m is also 0. So that's total amplitude, meaning that let me now come down total amplitude. That's amplitude due to S1 but is equal to amplitude to S2 is equal to 0. We had this together. This is allowed. But this one, we don't have the intensity together. So for an intensity here means that to do with the source of one and the second one. This is total one that's appearing. And for me to have total to be 0, now that means for them to be 0, that means they must be equal and they must be opposite. Look at it now. I want to add these two together and I'm going to get 0. So that means the amplitude must be equal, they must be opposite. Are you getting the point? For me to have these two to be equal to 0.
Yes, sir.
Okay, fine. So that means if this is A, this also must be minus A. The eventually going to give me 0. So that settles this way. That means now if intensity is 0 at M, it means amplitude at M is also 0. So what can you going to write? So if you come back here now, so it means amplitude of X and X, this and this have same amplitude, which is correct. Is that understood from what I explained here to be 0? That means they must be equal.
Yes, sir.
Okay, fine. So this point is gone. Now you now come back. When you have amplitude to be 0, they are equal and opposite. That means what is called, we call it destructive interference. Destructive interference occurs. Destructive interference. For under destructive interference, there's something called, we talk of path difference. Then we talk of phase difference. So for destructive interference, path difference is given. If you check the note, this is a path difference. So this is a path difference, destructive interference. This is the path difference. The same thing, phase difference is 180. The first one, the formula is, okay, I mean, I don't want to disrupt this, sir. I'll just say. So the formula is, the first difference is, I think is, we prove it that day. I don't want to prove it again. But the first angle here, the phase angle, when two waves are in phase, they are out of phase difference is 180 degrees. So these are the things that will have happened before we can say the intensity is 0 at M. This is accepted, accepted, accepted. So all these three will happen before we can say it is 0 at M. So when it's 0 at M, it means destructive interference. What's the destructive interference mean? Path difference is ln lambda plus lambda over 2, or phase difference is 180 degrees, or pi plus, I think pi plus n pi. And I think that's the formula. So n is 0, put 0 here, you have only 180, you have pi. Pi is 180 degrees, so that's all. So this is the formula for that one. You go and check your note. So that is that. Is that taken?
Yes.
Okay. Now, we now have the part B now. The speed of the sound in air is given. The frequency of the sound, this and this, is increased. Is increased. Determine the number of maximum. Okay, we increase frequency from here to here. So what number of maximum that will be detected? So if we have intensity, let's go and calculate the wavelength. No, the wavelength first. The wavelength first. Let's see. No, first of all, let's go and calculate. Let's calculate the path difference first. You need to calculate. In fact, we need all this type of question. So maybe the next class now is going to be on waves, to solve question on waves. That's why I've suggested that we should do it like we did this topic there now. We've not even solved question on that topic by topic and solve question deeply. So that's the way that's the way you can capture all these things. So we need to solve all this. So let's calculate the path difference first. What's the path difference? Path difference means moving to this point. You have to go and calculate the path difference. Path difference means you have two routes to move. You moving from X to X1 to M and what? X2 to M. So what's now the difference in the distance covered? That's called path difference. So what will be the difference in the distance covered? That's called path difference.
128.
So in this case, okay, what's the distance here? Look for this one now. Call this way X. Oh, yeah, Pythagoras. What's it going to?
128. 128.
128 meters. So in this case now, the meaning is that someone wants to move from X1 to M, and S2 is also moved from S2 also moves to M. What's the difference in distance covered? That's called path difference between the two. So we have S1M as 100. We have S2M as 128. What's now the difference in the parts? So that's called part difference. The part difference, let me call it delta S. Part difference means the difference in the distance covered by the two. This one move from x1 to P, x1 moves to M, S2 moves to M, S1 moves to M. What's the difference in distance covered? That's part difference. That's 128 minus 100. That's 28 centimeter. That's part difference. Now, this part difference, you are going to convert it to wavelength to know. We are going to convert it to wavelength to know, are we going to form maximum? Are we going to form bright fringes or dark fringes? So are we going to form construct interference or destruct interference? So how do we convert the part difference to wavelength? So in this case, so you need to calculate the wavelength. We are given the speed as 330. So frequency is given. So we have frequency 1000, that kilo 1000 hertz. I look for wavelength 1. Speed is equal to f lambda. I look for wavelength 1 for me. The same thing. Look for wavelength 2. We have frequency 2 as 4000 hertz. 1000 hertz. If you can hear me, yeah, look for wavelength 2.
0.3
Wavelength
meters, the first one.
1 is what?
0.33 meters.
0.33 meters. Okay. Wavelength, so that gives me in centimeter times 100,
33 in centimeter.
30, 33 centimeter. Okay, fine. 33 centimeter. Wavelength 2.
Other one is 8.25 centimeters.
Okay, 8.25 centimeter or meter? Centimeter. Okay, centimeter.
Meters. I already
Now,
converted.
okay, centimeter. Now I want to know the part. Let's go and look for part difference. Now, part difference is this. Is 28 centimeter. So in terms of wavelength, I want to see in terms of wavelength what's going to be. So meaning that, so let me see. If I want to wait a minute, if I want to make use of this, this. So between the 28 and and uh, 28 and this wait 28 and this, I have maximum of 33 run down to 8.25. This is this. Now let me see, let me convert this 28 centimeter. Now that's the part different. So but am I okay? I'm not even given the wavelength. I calculated it. Okay, wait, 28 centimeter. Then this is the wavelength. One wavelength. Okay, 28. Wait, hertz here. Part difference is this. I want to convert it and see what am I going to form. Am I forming? Is it going to be destructive or constructive? That's what I want to confirm from here now. It's going to destructive or not constructive. Okay, fine. I have already have 28 of part difference. What do you say?
Can't see the. No,
You
it's
can see the
fine
screen
now.
again.
No, it's fine. It's fine now.
Okay. Maybe it's work at your hand, making this need to just log off. Yeah. Now I have 20 centimeter. Ranging from here to here, you can see is acceptable. Now let me see. One wavelength. There's something I want to do. Well, let me give me something I want to do. I need to do something here. So if I have one wavelength, if I have a wavelength, let me see it again. Let me just I need something here too. Okay, at n. Oh, there's no name. It has been confirmed here. At n already, we know is the phase difference is 0. Okay, okay. It's 180. It's destructive interference that is there. Okay, destructive interference. Fine. This is what I have here normally. So now normal path difference is n lambda plus lambda over 2. This is what happens there. So what is this? 28. That was to get as 28. Now let me go and get wavelength that I can get. How many wavelengths I'm going to get between this and this? So that's what I want to get. How many wavelengths will I get between this and the ranging from here to here? So if the first one, this is if I put n to be 0, let me say put n to be 0. Get the wavelength. I have wavelength that's n plus 1 over 2. Put n to be 0. Go and look for wavelength. When n is equal to 0, what's the wavelength? When n is equal to 1, what's the wavelength? When n is equal to what's the wave? N is equal to 2, what's the wavelength? So let me see what will happen. So do all this thing for me in your calculation. Let me see. When n is equal to 3.
N is 0. The
Mm-hmm.
wavelength is 56.
The wavelength is what?
56.
56. 56. Okay, fine. When n is equal to 1.
And then when n is equals to 1, it's 18.7. 18.7.
18.7. 18.7. N is equal to 2. We are looking for T. We are looking between this and this. But this is the range. This is the range given now.
Yes, 11.2.
11.2. Is still within the range? Okay, fine. Yeah. Let's go to 3. No one. That's how they call it 4 marks.
8.
8. 8. Just 8, Abby.
Yes.
Okay, which is also possible. It's within the range. Okay. Yeah. See, n is equal to 4. Let me try it last. I don't think this will go beyond. It's equal to 4.
When n is equals to 4.
Yeah, let's go to 4.
6.2.
Oh, 6.2 is below. Yeah. See now, when we calculated this is the range given from the range of 1 kilowatt to 4 kilowatt. We got the frequency wavelength of 33 to 8 point. So the range obtained is 33 centimeter to 8.25 centimeter. From the power difference, see what we got. Don't worry, the time has gone. We'll might continue again, but we'll finish this right now. But I can also explain next time. So we're going to do all this time. So next time, let's even say we are going to do with question now. Now, see what we have here. We have 56, 80.7. We have 11.2. We have 8. We have 6 point this. So in this case, which one is not in which one they are in the range? This one is in the range.
And
This is
7.
not in the range. This one is there, am I
11.
right? From here, is there, is there. Is this one there?
Which one?
No. 6.2 is not in the range.
Not. It's not.
Okay. So how many do we have now? 1, 2, 3.
Only 2 say. Also 8 is not in the range.
Okay, okay, 8 is below. Thank you. 8 is only 2 self. Thank you. Only 2. Only these 2 are possible. So in the question, so the question saying, what's the question saying, Gansel? So the
Say.
number was maximum. Only 2 maximum. But you have to do some calculation like this. So only 2 maximum possible. And with this, you calculate this. So you calculate the part difference. That's what they want to see. The part difference that we did there, you calculate this one. They want to see this one. Fine. They want to see this and this, and they want to see all these points. And how you now say only 2 are within the range. So that's all. Only 2 are within the range.
Let me ask you a question. What is a minima and a maximum say?
What's what?
A minima and a maximum.
The minimum is what?
What what is a minima and a maxima? Like, what do they mean by minima?
We just the minimal is saying destructive interference. Maximum is a constructive interference. So that's what that gave me. So minimum means destructive or dark fringes. Maximum means constructive or bright fringes. So that's all. So on this note, in fact, we've taken more time. So we stop here. So
Maxima is constructive.
is that what?
Maxima is constructive,
Constructive for maximum, constructive interference or bright
or
fringes.
which is bright. Okay.
Minimum means
Okay,
destructive or dark fringes.
one more
Okay.
question, a quick question, really. Say, where
Ah,
does that yeah, the one for 2n plus 1, where does it apply? The one
and this
that
is when
is
it's
in your name.
construct. When I read your note, though, I have explained all this at the beginning. Then, so is when it's constructive, destructive interference. Go and read it, the whole note against next class. Instead of Friday, please find time to read this waves. So Friday we are going to dig
Okay.
deep on waves, and it's going to be on waves. That's what I suggested, that if you pick a topic, let's deep question on it so that you can understand it deeply, not just moving up and down. You won't get the concept. So we are going back to that concept now. So let's say we're on waves right now. So we are still going to be on wave for this while. So we are going
Yes.
to see different questions on waves now. So see you next time, because I'm supposed to have started something since, but I don't know what. So see you next class. Have a wonderful night. Oh, man.